Ever wondered what it would be like to visit one of the most magnificent and terrifying objects in the universe? Forget black holes or neutron stars for a moment. Let's talk about luminous blue variable stars, or LBVs. These are the rock stars of the cosmos, massive, incredibly bright, and notoriously unstable. So, what if you could take a trip and fall right into one? Grab your imaginary spaceship, because we're about to find out. First off, getting close would be a spectacle unlike any other. LBVs are giants, some over 100 times the mass of our Sun and millions of times brighter. From a distance, you'd see a colossal, shimmering blue-white orb, so intense it would outshine everything around it. These stars are so luminous that the light itself exerts a powerful pressure, constantly pushing their outer layers away. You'd be flying through a stellar wind that's thousands of times stronger than our Sun's, a hurricane of charged particles moving at incredible speeds. As you approach, the sheer heat would be the first real challenge. The surface temperatures of LBVs can exceed 25,000 degrees Celsius, making our Sun's 5,500 degrees seem like a cool spring day. Your spacecraft would need shielding beyond anything we can currently imagine to prevent being instantly vaporized. The radiation would be another immense hurdle. You'd be bombarded with a torrent of ultraviolet and X-rays, a lethal dose that would fry any unprotected equipment and, well, you. But let's say your futuristic ship can handle the heat and radiation. Now for the main event, the star itself. An LBV doesn't have a solid surface like a planet. It's a turbulent ball of superheated plasma. Falling in would be more like sinking into an infinitely dense and scorching hot ocean. The gravity here is immense. As you descend, the star's gravitational pull would become overwhelmingly strong, stretching and squeezing your ship in a process called spaghettification, the same thing that happens near a black hole. What makes LBVs truly special, though, is their volatility. They are famous for sudden, violent outbursts. Without warning, the star could erupt, shedding massive amounts of its own material in an explosion that doesn't quite destroy the star, but is powerful enough to be mistaken for a supernova. These are called giant eruptions. If you were caught in one, you'd be engulfed by a wave of stellar matter equivalent to several times the mass of our entire solar system, all moving at thousands of kilometers per second. There would be no escape. Even without a giant eruption, the star's atmosphere is a chaotic mess. You'd witness colossal magnetic loops and solar flares dwarfing anything in our own solar system. Convection cells the size of entire continents would churn the plasma, creating a mesmerizing but deadly dance of light and energy. The pressure would increase exponentially as you sink deeper, crushing your ship until it was nothing but a collection of atoms, which would then be assimilated into the star's fusion core. Ultimately, your journey would end where the star's life begins, in the core. Here, unimaginable pressures and temperatures fuse hydrogen into helium, releasing the very energy that makes the star shine. You wouldn't just be destroyed. Your matter would become fuel for this cosmic furnace, contributing, in a tiny way, to its brilliant but short-lived existence. These magnificent stars burn so brightly, they live for only a few million years, a mere blink of an eye in cosmic time before ending their lives in a spectacular supernova. So, falling into a luminous blue variable star would be a one-way trip, a journey into the heart of one of nature's most extreme creations. It's a beautiful, terrifying thought, and a great reminder of the sheer power and scale of our universe. Thanks for joining me on this cosmic adventure. If you enjoyed this, don't forget to hit that like button, subscribe for more what-if scenarios, and ring the bell so you never miss an upload. See you next time.